All right, CP Physics students. This is still in section 3.1. This is where we left off in our last time together. The velocity of time graphs of the four cars are shown. So we're going to finish up 3.1 and then we're going to do an example. So here's our last thing. So remember the chart that you just did. Here it is where you looked at the velocity and the acceleration. Now let's apply that to this graph. All right. Which of the four lines indicate that this car is slowing down? Explain. So here's my velocity versus time graph. So I can look at this two different ways. So the lines, let's take object number one. Here's the velocity. Let's call that 10. And let's call this 5 meters per second. And notice the curve for line one, the object at time equals 0. Here's the time curve. We'll call that in seconds. At 10 meters per second, and it's traveling, it's moving towards the horizontal axis. So it's actually going from a pi number going towards the x-axis. So object one is slowing down. Object two is slowing down because of the same thing. He starts at 5 and he is getting smaller and smaller and smaller, just not at as fast of a rate. Now, some of you are going to think that number 3 is slowing down just because of the slope. Well, let's look at that. Call that -1. Call this, I don't know, -10 meters per second. Object 3 is getting larger and larger in the negative direction. It's getting farther away from velocity of 0. It's just speeding up in the negative direction. Okay. Now and then 4. Let's look at number 4. We're asking for ones that are slowing down. Number 4 is at -10 meters per second, and then it's getting a smaller and smaller negative number. So let's assume somewhere, let's look at this guy right here, and let's assume that that is -5 meters per second. It was at 10 meters per second at time 0. That just means 10 meters per second to the left. And then it's at -5 meters per second or 5 meters per second to the left. So even though it's a positive slope, it's slowing down. Now remember our little signs. Let's look at all the accelerations. So this acceleration, so acceleration for object 1 has a negative sign, and that's because the slope is negative, because slope of a velocity versus time curve is acceleration. Acceleration for object 2 is also negative. Acceleration for object 3 is negative. Acceleration, how do I know that? Because of the sign of the slope. Acceleration for object 4 has a positive sign. Now let's go and look at object 1. I want to look at the sign of the velocity. Okay, and the sign of acceleration. All right, so object 1, the velocity is positive, it's above the horizontal. What's the sign of the acceleration? It's negative, has to be slowing down, and sure enough, it is. Object number 2, what's the velocity sign? Velocity is positive. Acceleration sign, negative, it's slowing. It's moving to the right, but it's slowing down. Object number 3, its velocity is negative. Acceleration is negative. It's speeding up towards the left. Number 4, its velocity has, I don't know why I want to say, oh, because it was number 4. Oh, brain's not working. Velocity is negative. Acceleration is positive. Huh. He's moving to the left, moving left. Signs are opposite, but slowing down. That negative number, the negative is just the direction. All right, so which of the 4 lines of the car is slowing down? Numbers 1, 2, and number 4. Explain, I just did in that table below. Which of the 4 lines indicates a car is speeding up? There's only one, and that is number 3, speeding up towards the left. Okay? All right. Last thing for today. We're going to do this example, and I guarantee you're going to need to come back to this example. Let's read this problem. A ferry makes a short run between 2 docks, one in Anacortes, Washington, and the other in Gooms Island. Ooh. The ferry moves in the positive X direction as it approaches Gooms Island. That's an important statement. I need to come back to that. With a speed of 7.4 meters per second. If the ferry slows to a stop, what is the average acceleration? The ferry returns to Anacortes dock with a speed of 7.3 meters per second. If it comes to a rest, okay. So we have all these things. So let's go in and turn. There's this. Let's do this. The ferry moves in a positive X direction as it approaches Gooms Island. Here's Gooms Island, and it's approaching, and we're calling that direction positive. So it's not to the right this time, okay? So that's okay, don't stress out. So to the left is positive. This is a really good exercise because this is going to help you understand how to keep track of all your negatives, okay? So now, with that very important piece of information, everything that's going to the left is a positive value. Everything that's going to the right is a negative value. All right, the ferry moves in a positive direction as it approaches with a speed of 7.4 meters per second. In fact, there it is. It's moving to the left, which is positive. So it has an initial, so I'm doing number A, its velocity initial is equal to a positive 7.4 meters per second because it was going to the left. If the ferry slows to a stop, so velocity final is equal to 0 meters per second in 12.3 seconds, what is the average acceleration? Well, I want to ask this question before I even do this problem. I have a positive velocity and I want the acceleration, I want it to come to a stop. So if I need it to slow down to a stop, what does my acceleration sign needs to be? I have to have a value that's negative because it's got to work against it. And so my answer better be negative or I did something wrong. Okay, so what's the equation for acceleration? Change in velocity over change in time. V final minus V initial over the time. What was the final velocity? 0 minus 7.4 meters per second over 12.3 seconds. And that gives me a acceleration of, oh, Mrs. Curry did something wrong. Oh, no, I didn't. I was looking at my answer to B, sorry. Yeah, okay, good. That will give me a negative 0.60 meters per second squared, okay? I need to double check that because I'm starting to second guess myself. So negative 7.4 divided by 12.3. Yes. Okay, good. All right, let's do some unit analysis. That's 7.4 was the top value, meters per second divided by 12.3 seconds. Notice I get meters per second squared, okay? All right, that's A. There it is. Now, that makes sense. We already expected to get a negative acceleration. Let's do part B. The ferry returns to the dock with a speed of 7.3. So which way is it going? It's going towards this guy. So it's moving towards the right. And we just got finished saying that towards the right was a negative value. So it has a velocity initial of a negative 7.3 meters per second to the right. And we called to the right negative. its final velocity was 0. It took a 13.1 seconds to come to a stop, and I want to know what the acceleration is. Now, I have to come to a stop. I have to slow down. Velocity is negative. What sign should acceleration end up being? It should be positive in order for it to slow it down to a stop. So acceleration is v final minus v initial over time. V final is 0 minus, what was the original velocity? A negative 7.3 meters per second divided by 13.1 seconds. So minus a minus gives me a positive, and I will find an acceleration of 0.56 meters per second squared. Okay, always ask yourself, does the sign make sense? It does. Okay, that's what I got for you today. We will be working on some of these problems over the next couple days, I would assume. I'm pretty sure you can handle it, but right now we're working on labs. Okay, so you want to get started on 3.1 lesson check? Go for it. It's coming your way anyway. So, but right now my focus is making sure you do your lab sections 1, 2, and 3. Collecting the data, reviewing how to graph if you need to with pivot, and then creating the graph. I believe it's position versus time data to get the graph. Okay, that's what I got. Come see me in office hours if you need help.